Alright guys, let's try this again. And for the third time. Okay, so we have an assignment 3. Alright, tres. 3. Alright. It's been a ride. Alright, we gonna finish out. We gonna graduate. We gonna make it. Alright, the idea is that threads in a process share the same memory space. Wow. That's crazy. But the real thing is only one thread can use the same shared memory. And we call that the critical section. That's just a fancy word for only mine at a time. Okay? And the way we solve this is using this fancy word called mutexes. What a weird word. Alright, so here's the problem. We have these 3 threads, right? A, B, C. Bang! They all want the shared memory. What happens? Corruption. Not in the government, but in the file. Alright, here's the solution. So let's pretend we had one bike, okay? Everyone wants to use this bike, okay? So we got A. Oh wait, this kind of looks like your assignment. And guess what? A wants to use the bike for 10 seconds. And his delay time is 0, so he comes in instantly. Okay, so A's first to arrive at the scene. You see that yellow thing at the bottom? It shows right here his time was 0. Okay? And we still have one free bike. Okay? A comes in into that mutex, that's what M stands for, and he enters it. That mutex then locks. Okay? Once this guy enters, it locks. Then, once it locks, this guy gets the bike, right? Takes the bike with him. Okay, basically changes the status of the bike. So if it was a boolean, it'd be true or false, or if it was a variable, you would like subtract one of the bikes. So you had 5 bikes. No, in this case we only have 1. So now we have 0 bikes, right? So then A gets his bike at time 0. Remember, still at time 0. Okay. All right, that all happens. Now B comes in at time 3, and it wants to use the bike for 5 seconds. Okay. It comes in, and the mutex is green, right? Because when A left, it unlocked the mutex. So B comes in, and it wants to access, and once it's in there, it locks it up, so no other thread can use this shared resource, if there is a shared resource, right? But there should be. The shared resource is whether a bike is there or not, right? It looks and it finds the number of bikes is 0. So what it does is it then says, okay, I have to wait. If you notice, the number waited is now 1, right? So then C, at time 7, right, because it comes in 4 seconds later, it wants to use the bike for 8 seconds, right? It comes in, and of course B unlocked it when it left the mutex, and it comes in, locks it up, figures out no bike, he got played. So this guy's got to wait too. He waits, or they wait, and they go on timeout too, and then unlocks the mutex, right? Because they're done with the shared resource. And D comes in at time 9, 2 seconds later, and they want to use the bike for 7 seconds. But guess what? This guy's still gonna have it till time 10, right? So none of these boys get in the bike, but he accesses it, locks it up, and then goes to the timeout zone, and the number of people waited is now 3, right? And you notice every time one entered, they locked it, used the critical section or the shared resource, used it, meaning they either evaluated whether there was a bike present or not, and then took that bike like A did, or had to wait, Anyways, so now we have 3 people waiting, right? And they all, once they left, they unlock, right? So at time 9, right? And the free bikes is 0, that's why they're all in the timeout zone, right? And you notice this is a queue, right? So if I were to use signal, which we'll talk about later, B will come out first, then C, then D, okay? It is a queue in this case. All right, back here, time 10, okay? So time 10, A is done with their bike, okay? A is done with their bike. They go back, and they have to put it back into the shared resource, right? They go back into that shared resource, lock it up, make sure no other thread can come in. And you know, they also I should mention this, the time it slept or the time it was using the bike was outside the critical section, right? The time it sleep is not shared by the resource. The bike is, but not the time it sleeps. So that should be outside the critical section. Okay, so it comes back, it drops off the bike, okay? And the number of free bikes goes up by 1, right? Drops off the bike, leaves, and then it leaves, and then that signal, it sends out a signal, okay, basically. And it, once that signal is hit, it allows the next thread to come out, and then this mutex unlocks. And A obviously doesn't disappear like that, but I wanted to free up some room. That will be done in the join, okay, which we'll talk about later. All right. Then B, same thing like A did. It'll lock it up. Remember, these guys are still on timeout. They don't come out randomly because we only signaled for one to come out, okay? That's the difference between signal and broadcast. There's conditional signal and there's conditional broadcast. If I broadcasted, these all these guys would come running. But since it was signal, only this guy came out. So B gets their time at time 10, gets its thing. And then, you know, number of free bikes goes to 0. The mutex is unlocked because we're done using the shared resource, which is basically taking a bike. And the number of weighted will stay at 3 because if you think about it, these guys will just be waiting. You know, I can't send them back to waiting because we're only signaling one at a time, so they will just slowly come out, right? So you can't have, what I'm trying to say, if you have 10 people, at most you can have 9 waiting, right? If you had only one bike, right? You'll never have more than that. Well, it depends on how many bikes are available. In this example, we only have 1. And it repeats just like A. That's what it's saying for the rest as well. And does the same. At time 15, yes, B will leave. And they'll do the same thing. It'll go here, drop off the bike, signal for C to come out. That's what it means, repeats just like A. All right, now, what time is it? It's code time. Okay, we need pthread library. Okay, pthread library, I think it works with only Linux. I'm not sure, but I'm pretty sure because that's why we had to get Ubuntu and whatever. How do we create a thread in the first place? Ooh, that almost sounded like I was whistling. How do we create a thread in the first place? Okay, we use pthread create from this library. So pthread create, these 1, 2, 3, 4s are basically each parameter of this. You need 4. This is like the default function in that library. And you need the address of the thread ID. So you're going to use that ampersand sign and then thread ID. You're going to set this one to null. You don't need to really worry about that. That's just default. The function name to create a thread. So that might not make sense right now, but you're basically going to send, when you create the thread, it's going to go to a function that does the mutex stuff that we just talked about previously, that will handle each thread. So the function name is basically the thread action name, basically, or each thread, and then what values are we passing to this function. So if you think about it, in your assignment, you're going to be passing the name of the client, the time it needs to sleep, right? The thread needs to sleep, and that's it, right? And then you're asking, where does the delay come in? Well, the delay is, you call it right before the pthread create is made, because basically what you're doing is you don't want to create a race condition where all these threads, like, they don't wait for each other and they just clash. You want to create it where each one comes one at a time. So then having that delay right here, then calling pthread create, is the reason why. If you notice in all the inputs, there's at least 1 second that gives time for this. It's like basically giving the other one a head start, right? There's at least 1 second to let this thread create itself, then allow the next thread. Because if there's not that 1 second, they'll like both try it at the same time. And the way this assignment set up, it doesn't handle if they come at the same time. It only handles if they come one after each other. Okay, so that delay is important. That'll make sense later. Anyways, and we obviously need to terminate these threads. So this is called right after we call pthread create. So you're gonna have, we'll explain this later, but basically it's the thread ID and null. Yeah, well, null you don't have to worry about. That can be 0, null pointer. Oh, right. So before we hop into the coding, even though I said we're getting coding, let's think of the things we need. Okay, we're gonna need these 3 things, which are part of that library, pthread library. And basically it's it's a function, but its function in the program. And mutex is to allow one thread access, right, to a section, right? That's what a mutex is for. Then we have this thing. It's called the signal, and it's to wake A. A means 1 waiting thread, right? Remember, B would come out, then C, but we didn't show all that, but only B came out. And then this thing is to make a thread wait, right? Because we made B wait, C wait, and D wait, right? And these are controlled by the same condition. This is what it means to switch, right? This mutex is controlled by one switch. And these 2 conditions are controlled by, these 2 functions are controlled by one condition. And then when do we do this? When one thread access shared. The yada yadas. Who knows? Okay, so this is to show, I don't know what I was trying to show here. I think it was to show that when we use the signal part, a number of weighted, it's just a recap. Oh, okay, so we're gonna, it was to focus on the mutex, which I don't have right now. Can I go back? No, I can't go back. Whatever. Anyways, this is the functionality of the mutex. Remember, the mutex only allows one thread to be in the critical section at a time, right? Because we don't want multiple people in there. Only one is invited to the party. So this guy goes in, he locks it up, lock up that house, and he leaves, and he unlocks the house, right? That's all the mutex does, right? So you need the mutex when you're accessing a critical section or a shared resource. Okay. And mutex locks and unlocks when a thread wants to access the critical section / shared resource. Easy. All right. So this is going to show you the 2 different signals. I think I start with the signal first. I'm not sure. Or no, the wait first. So A comes in, does its thing. It's the same thing as before. It's just going to show you where that signal comes from to make it wait. So B comes in, realize, okay, there's no bike for me, locks it. It goes there. It should be, yep, that's like the signal that said, hey, now we need to wait, right? We need to wait, right? We need to wait, right? And then, and so forth. I didn't show it for the rest because that'd take too much time, and this thing does the same thing. But what I really want to emphasize that I didn't emphasize on the last slide, for both of these, and then this is the signal. So when to awake a thread, so B, we're gonna awake B. The signal is that this mutex has to be locked, when this happens. So it has to happen between a lock and an unlock, which we'll see in a bit. And so this A leaves and he signals, but notice this mutex is still locked, right? And signals for B to come out. B comes out, then we unlock, and A does its thing. Anyways, that was all the point, but this is probably all. This is all gonna happen in that function to create a thread. This is basically it. Notice the 2 conditional signals, A and B. This signal must take between a mutex lock and unlock region. The general outline is this. You lock the mutex, the thread comes in, not enough resources, you put it in timeout. Okay? If there is, you use the resource -1. Okay? And then you unlock the mutex. Notice this signal is inside this locked region. And we don't unlock until it's finished. And actually this B part will unlock the mutex for you. We'll talk about that later. and then we let that thread use the resource for an amount of time. That's considering that it didn't go in timeout, right? Like A was able to use the resource for that amount of time, B, C, and D weren't, right? And then when they're done using that resource, we again lock the mutex, get that resource back. This is the shared resource. That resource, not enough resources or giving that resource back, that's the shared resource, which in our example is a bike. Okay, so we +1, and we single one of the threads to wake up, and then we unlock the mutex. Okay. Alrighty. Okay, I don't know why I did that. I was useless. Anyways, important libraries for the mutex / signals or conditions. pthread mutex, you'll define this globally, both of these, at the very top of your program. That's pretty simple. So you only need one of each. Okay. Okie dokie. How to use the mutex. So it's just pulling out the first one. You define the mutex global, right? And then you do pthread lock, name of mutex, and unlock, right? Because it has to be within a lock and unlock region. That's all this is saying. And now we define a global. That's the condition. Remember, one condition handles both of those two separate functions, right? Like one to awake a thread and one to put a thread to sleep, right? The sleep timeout and the wake timeout. Yep, it's right there. Anyways, we're gonna use that same thing again, and then we're gonna talk about each one. So the conditional wait takes the name condition and the name of the mutex. And the reason why name and mutex is passed here is because this will actually unlock the mutex as well. Because we don't hit this part right here, right? We just put it in timeout, so it doesn't actually go here because we don't -1 the resource. So here it does both, okay? Hopefully that makes sense. And then the awake thread, yeah, you just need to pass it because we are gonna unlock the mutex. All right. Here we just, yeah, it's all here. Now it's time for a little bit of coding. Okay. And I'll get back to that in the next part. But basically, in the function part of this code, where it says void -star is where, is where all the all that lock and unlock action happens. It doesn't happen in the main, it happens in that function. Because in that function, the thread takes action, right? Because we call pthread create, and in that function, the thread takes action. So all the lock and unlock jibber jabber is going to happen in there, alright? So that's all from me for today. Alright guys, so this is the code I was talking about in the slides, and it's a very short example of how to create a thread and with the respective function. So basically you're gonna want to read in every line that you get from the file, right? And each line represents a client, right? And if let's say in that example I had 4 clients, A, B, C, D, which is some Alice, Bob, Carolina, and the dean, haha. And basically this would be 4, right? But that has to change based on the input. Here it's just static as 2. And here I just created a list of how much money they have, but in reality you would read the values from the file and assign them their delay and their service time, right? And you would use that doing a struct, right? Here I'm just using integers, so I'm not using a struct. So each one of these threads are gonna just have a simple integer. So I'm just passing the address of each of these integers into the thread. And basically what happens is, remember, here we're going to pass the address of their ID, the thread ID we created up here. Null pointer, 0, null, all work. The name of the function, the thread function, which is up here. And then we're going to need the value we're passing into the thread, right? And this will be a struct in your case, right? So basically that comes in here, and it's called thread info, or in your case client info, but I'm just keeping it simple as thread info. And here I'm going to create a variable called cache info, which is a pointer. And then I'm going to extract the information from thread info, right? Right, because it's the same type. Make it the same type, sorry, and then point to it, right? Because this is the address. Point to the address, save it in a pointer, then point to the memory at that address. Yeah, I got it. Don't worry, guys, I got it. If I messed up, my bad. And then you just money total is just to represent how you're gonna update the number of clients that waited, or what was it? Yeah, that's it, right? Number of clients that waited. You're just gonna update that here inside the threads, right? And so what the delay is for, right? Here you're gonna do the sleep dot the service time, right? You're gonna read that from the struct, but the delay actually doesn't happen in the thread function. It actually happens down here. You actually do the delay here as you're creating the thread, because you're like, why do we do that? And let's comment this out and see why. Okay, let me sleep for no seconds. It's gonna run a lot faster, but see, 55:22, right? At some point it'll be 22:55. It's not making my point. You see that? Now they're together, and we'll get different outputs at some point. Yeah, 22:55. And it's because they're racing each other there. So the delay is to basically let the other one get a head start, so you don't have that problem. In a real situation, you'd actually give it a property, and when it comes here, you would check whether it has that property, and if not, you make it wait. But here we're making it wait based on making it sleep, which is kind of cool, I guess, and actually makes it a little more simple. That's pretty much it. And this is a little example. It should help you really get ahead on the assignment. Oh, one thing I need to mention is we're going to be using these values, right? pthread mutex and conditional. Make sure you don't copy my names. Use your own. And so you're going to want to name it something like name of mutex, right? Be creative. Like name it something that you'll maybe like one at a time, or something cool. And then the condition could be like, what's the condition? They free, or something funny. Like they free, like the clerks are free, or something creative. This one you need to initialize. So there's this fancy thing called pthread conditional initializer. Okay. This one you don't initialize because you just lock and unlock it. It should work fine unless, oh yeah, it worked fine. Look at that. And then when you let's say I wanted to do I think it's pthread lock, pthread mutex lock. It's literally in the name. I'm kind of stupid sometimes. Pthread mutex lock. You would pass these by their addresses. So name of mutex, bada bing, bada bop, and it's locked. So this thing is never gonna end because I never unlock it. Well, you see why. That's why you need to lock and unlock. So let's see. Let's pretend. Let's do it here. Oh, okay, my bad, bro. My bad, bro. I'll do it right here. Unlock, right? Bang. Everything works snazzy and jazzy. Alright, that's pretty much it. But this is not correct because you only changed the shared resource. This is unnecessary. Alright, that's all I got. Good luck.